Hello, grade 12. Here, Mr. G. We're going to be doing the video on the solution of question 4 from February-March 2018. This question is related to momentum and impulse, okay? This question is not that hard, so let's have a look how to solve the question. The question says, the diagram below shows two skateboards, A and B, initially at rest, with a cat standing on skateboard A. The skateboards are in a straight line, one in front of the other, and a short distance apart. The surface is flat, frictionless, and horizontal. Okay? State the principle of conservation of linear momentum inward. That one is quite easy. We don't have to continue reading for the question. Let's answer that one, and then we'll give you time to read all the other part of the question. Okay? So solution 4.1 is the principle of conservation of linear momentum. This principle states that the total linear momentum of a closed or isolated system remains constant. Remains constant. The total linear momentum of a closed system remains constant. Here is closed or isolated, but you don't have to write both words. So it's either closed or isolated. Either one. You don't have to write both. Okay? Writing closed is just enough. Total linear momentum of a closed system remains constant, and there's 2 marks for that answer. Let's go to question 4.2, but let's go to read first because we did not read. Okay? Now, the question said each skateboard has a mass of 3.5 kilograms. So the mass A is equal to 3.5 kilograms. All right? And mass B here is equal to 3.5 kilograms as well. The cat of mass 2.6 kilograms jumped from skateboard A. So initially the cat is on skateboard A. You can see it there in the first picture. Okay? And the mass of the cat, we're going to write it here, is equal to 2.6 kilograms. With a horizontal velocity of 3 meters per second. So remember, the velocity of the cat is horizontal. It's moving in that direction, okay? That is an important data here. And lands on skateboard B with a velocity of 3 meters per second, okay? So, refer to the diagram and calculate the velocity of the skateboard A just after the cat has jumped. Now, first of all, let's identify the system. That is important, the system. What are the objects involved in this first question, in this first part of the question? Those are skateboard A and the cat. Skateboard B is not part of the system. It's a cat on skateboard, and it's the cat that jumped from the skateboard. So that's all you need to remember here. So let's quickly write the data. So what we have that the mass A is equal to 3.5 kilograms. We have that the mass of the cat, remember we're working with skateboard A and the cat. The mass of the cat is 2.6 kilograms. We know that the initial velocity of A is equal to 0. They are not moving, and the initial velocity of the cat is equal to 0, because it's right on the skateboard and they are not moving. The question said the cat is on the skateboard is not moving. It's at the beginning here, cat standing on skateboard A. Later the cat jumps from the skateboard. All right, so the cat jumps. We say initial velocity of 3 meters per second. With a final velocity, the initial velocity 0, of 3 meters per second to the right. Okay, to the right. And then you are looking for the final velocity of the skateboard A. That is important. So we have a before and we have an after. What is before? Before is when the cat is on the skateboard A. And after is when the cat jumps from the skateboard A. So using the principle, we can say that the mass of the skateboard A multiplied by the initial velocity of skateboard A plus mass of the cat, initial velocity of the cat, is equal to mass of the skateboard A multiplied by the final velocity of skateboard A plus mass of the cat multiplied by the final velocity of the cat. Okay, this is the information. This is before the cat jumps. This is after. Okay, now if you want, you can say that all this is a system. At the beginning they are together, so the initial velocity of the cat and the skateboard multiplied by the product of the mass of skateboard A plus mass of the cat is equal to ma velocity final A plus mass cat final velocity cat. I'm using C for cat. Okay, so either side is the same. At the end is not a difference, and then all we have to do is just substitute the numbers of the data we have. The initial velocity is 0, the mass of the skateboard is 3,5 plus 2,6, which is the mass of the cat, and this is equal to mass of A, which is 3,5 multiplied by the final velocity of skateboard A. We are looking for that, plus the mass of the cat, which is 2,6, and the final velocity of the cat is 3 meters per second. 3 meters per second. So all this left hand side is going to be 0. Is the product by 0. When you solve this one, you will get 0 is equal to 3,5 final velocity A plus 7,8. If you rearrange this one, you have that 7,8 divided by 3,5 is equal to the final velocity of A. The 7,5 is going negative for the other side, and this is equal to 2,23 negative 2,23 meters per second. So what means that this negative is 2,23. So the final velocity of A is equal to 2,23. Let me just write the number there. 2,23 meters per second to the left. To the left. So here is the question. If we're going to see the marks, you will get 1 mark for the law. And let's use the red color. You will get 1 mark for the law. You will get 1 mark for the substitution of the left hand side. You will get 1 mark for the substitution of the right hand side. 1 substitution for the magnitude of the velocity, and in this question they gave a mark for the direction. So it's 1, 2, 3, 4, and 5. A total of 5 marks for this question. I don't think it's difficult. I think it's understandable. Okay, so let's go to question 4.3. Question 4.3. All right, so let's read question 4.3. They say immediately after the cat has landed, the cat and the skateboard B move horizontally to the right at 1,25 meters per second. Calculate the magnitude of the impulse on skateboard B as a result of the cat's landing. So we are looking for the impulse. Okay, we're looking for impulse. Now, what do we know? The impulse is equal to the change in momentum. All right, now what we need to understand here, they say calculate the magnitude of the impulse, the skateboard B as a result of the cat's landing. So we need to know the velocity of the skateboard B. Okay, so the different skateboard B is the following, or the data. We know that the mass of skateboard B is equal as the mass of the skateboard A, which is equal to 3,5. So 3,5 kilograms. 3,5 kilograms. Now, the initial velocity of skateboard B is equal to 0. It was not moving. Neither of them were moving. They were at rest. And the final velocity of the skateboard B is given in the question. They say that calculate the magnitude of the impulse immediately after the cat has landed. The cat and the skateboard B move at 1,28 meters per second. 1,28 meters per second. Okay? In the same direction as it was moving before, so it's to the right. It's to the right. Okay? So that's all, and you're looking for the impulse. Okay? So, if you remember, the impulse momentum theorem say that the impulse in ordinary case we use J for the symbol. You can say net force multiplied by time. That is another way of representing impulse, and this is equal to change in momentum. Okay, change in momentum is the product of mass bracket final velocity minus initial velocity. And if you substitute the numbers, this is 3,5 bracket, the final velocity is 1,28, the initial is 0. When you calculate here, you get that the answer is 4,48 Newton second. That is the answer. They set the magnitude of the impulse, therefore no direction. Okay, only the magnitude. So this is the complete answer. The marks in this question are 1 for the equation. Any of those formulas will give you 1 mark. 1 for the whole substitution and 1 for the final answer. Those are 3 marks. When you count everything, the total is 10. This question is not a big problem, it's not a big threat, but it's a good practice. Thank you for watching. I hope it is clear. Good luck.